All right, so we started reviewing our unit yesterday. Now today we're gonna finish reviewing our unit. This is what we saw this week. So from our notes, I'm gonna be working questions 55 through 58. Okay, 55 through 58. Looking at the first two, 55 and 56, I'm asked to draw a box and whisker plot for each data set. So let's take a look at those two questions a little bit closer. The first thing I'm gonna do, I'm gonna list my numbers from small to large. So looking at number 55, I'm gonna list my numbers from small to large. So there, I need to find my median. I need to find the number in the middle. The way I'm gonna find that, I'm gonna cancel the smallest number and the largest number on my list. And again, and again, and again. My median happens to be 29.5. The median, it separates my lower half and my upper half. Now looking at my lower half, looking at the first four numbers, I'm gonna find the center of that, which is what we call the lower quartile. That is right in between 22 and 24.1. For me to know exactly what number that is, I'm gonna add those two numbers, 22 plus 24.1 divided by 2, and that gives me 23.05. So I know my lower quartile is 23.5. For me to find my upper quartile, looking at the last four numbers, let me find right in between, right in the middle. It's right there. So my upper quartiles in between 33.1 and 35.6. For me to know exactly what number it is, let me add those two numbers divided by 2, and that gives me 34.35. So for my box and whisker plot, which is what I'm going to do, I'm going to need the smallest and the largest number. I'm going to need my lower quartile, my upper quartile, and I'm going to need my mean, which I have everything. On the number line, this is what I'm going to do. Notice my lowest numbered and my biggest numbered, I represent them as dots. Notice 19.6 is a little to the left of 20. 48.5, it's a little bit to the right of 48. My biggest and my smallest, I represented as dots. Now in the center, my lower quartile, 23.05, notice I represented as a line. The median, 29.5, I also represent that as a line. And then the upper quartile, 34.35, you notice I represent that as a line. So my lower quartile, my median, and my upper quartile, all three of them, I represent them as a line. Then I close them out as a box. And that's it. It looks like a box in the center with whiskers on the side. Again, statistician, we talked about this a couple of days ago. Statisticians, they look at these because they're like, all right, most numbers are to the left of it. Most numbers are low, right? Statisticians look at these. And then like I mentioned before, some of you guys will be like, am I going to become a statistician? And my answer to that is, why not? Go for it. Okay, now looking at question number 56. Let me list my numbers from small to large. Let me find the median. Let me cancel the smallest numbered and the largest numbered. And again, 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 and again. My median is 30.3. Now to the left of my median, there's 5 numbers. So I'm gonna say right in the middle is 25.3. That's my lower quartile. On the up numbers, there's 5 numbers as well. And I'm gonna say in the middle is 32.7. So notice how I need my smallest number, my highest number. Remember, I'm going to represent those as dots. My lower quartile, the median, and the upper quartile, I'm going to represent those as lines on a number line. So you guys can see my lowest number, my biggest number, they're dots. My lower quartile, my median, and my upper quartile, notice I represent those as lines on the number line. I close the lines in the center as a box, and I connect it with whiskers on the dots at the side. For your homework, I'm going to give this to you as a multiple choice, so you guys will be able to identify those. Right? We cannot graph, but you guys can identify those. Now, another thing that we saw already, so we need to review this, bivariate data. Bivariate. I talk about this. Bi means two, variate means variable. So we're talking about two variables. Now here, we can see we're talking about GDP per capita and a corruption score. I can give you guys information as a table. We can see it on the left. And I'm also giving it to you as a graph. We're looking at the right. My first question here says, what does the y-intercept of this function represent? So if I was to make a line, if I was to connect my line, let's do this line. If I was to connect this line until I cross the y-axis, what does this point represent? Right? From the GDP, I notice it will give me a number. In this case, probably a negative number. So I get a negative number for the GDP, but for the corruption score, the number on the left, I mean at the bottom, notice how it will go down all the way to 0. Okay. So again, the GDP will be a negative number. The corruption score will be to 0. So I'm going to say the y-intercept in this case will represent the GDP per capita of a country with a corruption of 0. A corruption score of 0. Okay, now looking at question B. According to the model, what will be the GDP per capita of a country with a corruption score of 44? Round your answer to the nearest dollar. Okay, so corruption score of 44. Corruption scores are the numbers at the bottom. 44, I'm going to draw a line by 44 all the way up until I cross my blue line. So let me just do this, right? 44 is about here. And I find where I cross my blue line. Now I'm going to do a horizontal line because I want to know this point gives me a number from the left. My question here is, what number is that? What I gave you guys the corruption score is 44. I want to know the GDP, which is the number in the left. Now we can estimate this. That looks less than 15,000, more than 10,000. So matter of fact, I want to estimate this to be 13,756. Do you have to be that exact? Not necessarily. For my homework, for my quizzes, I accept a range of for answers, possible answers. What I mean with that, there's a smallest number that I accept, and there's a biggest number that I accept, and everything in between. I'm not telling you guys right now what the range is, but what I'm going for is you don't have to be that exact. I'm accepting a range of possible solutions. So there's a minimum number that I accept, there's a biggest number that I accept, and everything in between. Now, some of you guys were to say that looks like 13,500. That is within my range, so it will be correct. I want to make sure that you know how to read this type of graphs. All right, let's take those red lines. Let me cancel those out. Now, question C. Using this model, a country with a corruption score of 82 will have what GDP per capita? All right, so I'm giving you the corruption score of 82. 82 is about here. I know it goes off the picture, and it's fine. We're estimating. And that will give me on the left a number about here. I'm going to estimate that to be 32,528. If I give you the GDP, I want to know the corruption score. If I give you the corruption score, I want to know the GDP per capita. From the two choices that I can give you, I'll give you one, and then you give me the corresponding number on the other side. Let's take a look at another example. Let's take a look at number 58. Now here, we're gonna see this. It's possible to calculate the probability that a school wins their first game in the National College Basketball Tournament. I have the rankings of some schools, right? I see the schools that ranked first place, third, fourth, eighth, ninth, and 11th. And I see what was the probability that they will win the first game. Now, question number A, it says, what does the y-intercept of this function represent? I'm not going to be looking at the table. I'm going to be looking more at the graph. the y-intercept is gonna give me a number. If I was to follow my line, we're gonna give me a positive number on the probability of winning the first game. But when it comes to ranking, it will give me a 0, right? From the rank, the numbers at the bottom, it's a 0. And the probability of winning is a positive number. So what does the y represent in this function? I'm gonna say represents the probability that the school ranked number 0 will win their first game. Now let's take a look at example B. According to the model, a school ranked number 6 has what probability of winning their first game? Okay, the ranking number 6, right? On the table, I don't have ranking number 6, so that's why I'm gonna use my graph. Ranking number 6 is right here. Right, from the ranks, the numbers at the bottom, I choose number 6, cross the line about there, and that represents a number on the left. Right, I'm asking, what is that number? I'm gonna estimate that. Let's see, I'm gonna estimate that to be about 66%. You don't have to write the percent symbol. You don't have to write the percent symbol in the homework, just the number, just 66. Looking at question number C. Using this model, all right, so let's erase these red lines from the graph. Using this model, a school ranked number 13. Okay, so number 13, it's about here. Has what probability of winning their first game? So that gives me about this number on the left, right? It's a little more than 20. And I'm gonna estimate that to be about 23. Okay. I could ask you guys, there's a school that has a 70% chance of winning the first game, 70. I will expect you guys to give me about 5.2, 5.3, somewhere around there. Okay. Make sure you guys finish your work. If you have any questions, you know how to find me.